can you predict which would take more energy to break? Is it going to be the UV photon needed to break the oxygen, or the UV photon needed to break ozone? Well, you need to go back and think about what is different between oxygen and ozone. And when I see oxygen, this is what I think as a chemist. I'm thinking about where the electrons are and the type of bond that exists between oxygen. It's a double covalent bond. And when I see ozone, I think something like this, that it actually exists somewhere between two extremes. We call them a resonance structure, that I'll model like this using the, okay, the bonds that exist between the atoms in ozone are somewhere between a double bond and a single bond. And since double bonds are stronger than single bonds, then the double bond is going to be stronger than the bond that's like, let's call it a 1.5 bond or something, some type of bond that exists between these two extremes. So I'm going to predict then, since this is a stronger bond, it's going to take more energy. Just imagine if you were holding onto some object very tight, it's going to take more energy to rip that object out of your hands. So too, if these two atoms are being held together by a tighter bond, it's going to take more energy to disrupt those bonds, that double bond we call it, to break apart those two oxygen atoms. So I'm going to predict that this is going to be a higher energy photon. So its different energy is within the UV spectrum is going to cause different types of chemical changes. And indeed, the wavelength of the UV radiation necessary to break the oxygen double bond is less than, remember, the shorter the wavelength, the higher the energy, less than or equal to 242 nanometers. So it has to be at least 242 nanometers or shorter to break that bond. And for the ozone, the wavelength within the ultraviolet region is less than or equal to 320 nanometers. So this is in the UVC region, and this is in the UVB region. So that's why we say that the ultraviolet light from the B is absorbed by ozone. The ultraviolet light in the C region is absorbed by oxygen and ozone, because it can be any wavelength less than or equal to this. So that's going to cover the B and the C region of the spectrum.